So here we have a different situation. Before we were given a table of values and we had to plot them on a graph. Here we've been given a graph with values already plotted on it, and I want you to fill out the table of values. So first thing we should do is figure out what this graph actually is. As the title suggests, this graph represents the cost of pens, where our x-axis is the number of pens and the y-axis is the cost in dollars. Now you'll notice this x-axis has been renamed N, and the y-axis has been renamed with a C. The C stands for cost, and the N stands for number of pens. It still behaves in the exact same way as if it was X and Y, it's just the letters have changed. Now I told you if we're filling out our table of values, the X values are always first. In this case, we're just going to call them N values. And the Y values are going to be our C values. Now to fill this out, we want to go to the first dot, the one that's going to have the lowest X or N value, which is this one. And if we went back down to the N axis or the X axis, the value is going to be 1. And the corresponding value on the y-axis is going to be 2. So you just start from the dot you're looking at and go over to the y-axis. So what this means is when n is 1, c is 2. And now we can look at our second dot. In this case, n is going to be 2. And when n is 2, C is 4. Stop the video and see if you can find the values for the final 2 dots. So in this case, for our third dot, the N value is 3. The C value is 6. And for our final one, the N value is 4. And when N is 4, C is 8. Perfect. Something that you can notice just by looking at the graph is this is a linear relation because the dots are forming a straight line. Now, what are some questions that we can ask about this? Well, looking at this graph, what would be the cost in dollars of 1 pen? Pause the video and see if you can figure that out. So in this case, if we want to find 1 pen, we go to the number of pens. We want 1 pen, and we would just go up to our dot and then go across. So 1 pen is going to cost us $2. 2 pens will cost us $4. 3 pens will cost us $6. And 4 pens will cost us $8. Here's a question. We know this forms a linear relation, which means all the dots form a straight line. My question for you is, instead of having n equals 1 or n equals 2, could I go in between these 2 points and put my own dot in the middle, but still keep it on this line? So for example, could I put a dot just right here? It's still keeping this as a linear relation. Is that possible? I want you to stop the video and think about that. Can we put a value in between these dots? Well, the answer is in some graphs we can put values in between dots as long as it stays with that relationship. In this case, we cannot put this dot here. And it really has nothing to do with math. It has to do with a real life situation. If I put a dot here, how many pens am I talking about? Well, I would have to go down to this axis, and this would be my number of pens. You'll notice it's about halfway between 1 and 2. So we're talking 1.5 pens. Now, is it possible to have 1.5 pens in real life? No. Sure, you could break off a pen and get 1.5, but you can't go to a store and ask for 1.5 pence. They're not going to give you a price for that. So in real life, it does not make sense to have values in between our dots. Same thing in between these two dots. If this is 2 pence and this is 3 pence, if we were to have a dot right here, we'd be talking about 2.5 pence. We cannot have that. So it's very important that in this situation, our dots are on whole numbers. So here we have another graph again with the values already plotted on there. We want to fill out our table of values, but first let's see what this graph is talking about. So the title says this graph represents the position of a car. And on our x-axis we have time in hours, and we're calling that t. And for our y-axis we have the distance in kilometers, and we're calling that d. So this is pretty much how far a car goes in a certain amount of time. Pause the video, see if you can fill out the table of values from this graph. First thing we have to do is realize that x is actually being called t. Notice in math we usually bend the bottom of the t just so it doesn't look like a plus sign. And our y values are being called d. So let's fill this out. We always want to start for the lowest values of x, which is always on the left side. In this case, this point t would be 0, and the d value would also be 0. So 0, 0. Then our next dot is right here. The t value is 2. The d value is 140. And then the next dot, our t value is 3. And our d value is 210. And then we have a dot where our t value is 4. And our d value is 280. Now, is this a linear relation? Yes, the dots still form a straight line. There's a little bit of a trick here because it looks like it's missing a dot here for 1 hour, but it still forms a straight line, so it's a linear relation. Now, here's a question similar to the previous graph. I have dots here and here. Is it possible to have values in between these dots? For example, is it possible for me to put a value right here? Let's take a look at this. Before we said we couldn't have something like 1.5 or 3.5 pence. Let's look at this example. Here we would have 2 hours and 3 hours. Let's say this is 2.5. Is it possible to have 2.5 hours? Yes. So it's not the same thing as a pen. We could have 2.5 hours. We could have 3.1 hours. It's possible to have values in between whole numbers. But we can't just look at the x value. We also have to look at the y value. So our y value would be in between 140 and 210. Is it possible to have values in between? Yes. You could have 150 kilometers or 160 kilometers. You could even have 151.2 kilometers. That's what we call continuous data. Now here's a difficult question. I want to know, what does this graph actually represent? I know the title says position of a car, but we have distance compared to time. And if you want to ever know on a graph what the line represents or what the points represents, you always take the y-axis and divide it by the x-axis. So in this case, if we want to know what that linear relation represents, it is distance divided by time. Now, what is distance divided by time? So distance divided by time is actually speed. So speed is equal to distance divided by time. And you actually might know this without even realizing it. Instead of thinking distance divided by time, let's look at the units. The units for distance is kilometers, and the units for time is hours. So instead of distance divided by time, let's think of it as kilometers divided by hours. Another way of saying that is kilometers per hour. And I know if you're driving in a car, you've probably heard of someone going 50 kilometers per hour or 100 kilometers per hour, and you know that is speed. So whenever you're unsure, you can always take the units in the y-axis divided by the units in the x-axis, and it will tell you what that line represents. So this line actually represents how fast the car is traveling. Now, how fast is this car traveling if we're talking about kilometers per hour? Well, what we can do is we can take one of these points and it will actually tell us. So I'm going to look at this point right here. Now we said speed is distance over time. At that point, what would the distance of the car have been? To find that, you start at this point and I want you to go to the y-axis, the d-axis. And the distance would be 140 kilometers. And we're going to divide that by the time. Now for that dot, to find the time, you go down to the x-axis and it's 2 hours. So the speed that that point represents is 140 kilometers divided by 2 hours. Now we can actually simplify this. What is 140 divided by 2? 70. And then we still have our units of kilometers per hour. Whenever you see this slash in kilometers per hour, that's the same as a fraction line. It's just some people find it easier to do it as a slash. So what this linear relation represents is the speed. Now you may be asking, okay, we did this dot, but what if we chose this dot? Well, let's take a look at those calculations. I'm now going to look at this dot and let's see if we can figure out the speed. Again, we said to find what this line represents, we have to go distance divided by time. What would the distance have been for that car at that point? 210 kilometers. So the distance is 210 kilometers. What would the time have been at that point? The time is on this axis and it's 3 hours. So we have 210 kilometers divided by 3 hours. Well, we can simplify this. We can do 210 divided by 3. And if you do that, you get 70. And the units are still kilometers divided by hours. Or we can say 70 kilometers per hour. So the speed is actually the same whether you use this dot or this dot. If you use this dot, it would be 280 divided by 4, and that would be 70 kilometers per hour.